How to find an arc length of a given curve. In this video, we will solve these problems and provide step-by-step solutions which involves exponential form and the sine and cosine function. Say for example, your friend Luffy went fishing and then after some time he caught this big fish. Notice that the tip of this rod and the string that connects to the mouth of this fish forms a curve. What is the arc length of this curve? To visualize this one, imagine that you pull this string from end to end so that you will have this illustration. And precisely, the arc length is simply the length of this string. And if your curve is given by the vector equation r of t, then we have the following formula. This is also equal to this one. A formula which is in terms of the derivatives of components of your r of t, where a and b are the parameters which describes the initial and terminal points of your curve. Let us use the formula to solve these problems step-by-step solution. The first item describes a helix which is, if viewed in xy plane, we have a radius equal to 3. Now, the second and third item looks terrifying, but if you know the trick, you can solve this one in under few minutes. Let's go. How to find the arc length of this curve RT from t equals 0 to t equals 2 pi. For the solution, let us first write our curve, which is this one, by the given. So here we have this one as your x, y, and z. So all of these are in terms of t. So step 1, find the derivatives. Meaning you need to look for dx over dt. So we derive this one. You have 3 times derivative of this one, sine of t. Simplifying, you will have dx over dt equal to negative 3 sine t. Then for this one, you have 3 cosine of t, which is 4 dy over dt. Now for dz over dt, so derivative of this one, that gives you 4. So r prime of t here is equal to this one. So you simply put this one as the first component of the derivative, this one for the second component, and this one for the third component. Okay, so now let us proceed to step 2. Step 2 here is to simplify the magnitude. So what magnitude? That is the magnitude of this one, r prime of t. By the formula, this is equal to the square of these components. So you simply add that one up. So that's why you have this one squared, and then this one also squared, and this one squared. So simplifying this one gives us 9 sine squared t. This one is 9 cosine squared t, and this one is 16. So here you factor out 9, and notice that by the identity you can simplify this one equate to 1. So that's why you will have 9 plus 16, which gives you square root of 25, and hence it is equal to 5. Now for the final step, step 3, which is to integrate. So here we have the formula for L, which is from t equals 0 to t equals 2 pi. So that's our A and B. And then we have the input magnitude of r prime of t dt. So based on our previous calculation, we have calculated this one is equal to 5. So this one simplified to 0 to 2 pi, 5 dt. So in integration, this is equal to 5t, which is evaluated from 0 to 2 pi. So again, if you simplify this one, this gives you 5 times 2 pi minus 5 times 0. So this one gives you 0. And hence, we have your answer equal to 10 pi. So that's the arc length of the curve from t equals 0 to t equals 2 pi. So what we did to solve this problem is, step 1, we find the derivatives. Step 2, simplify the magnitude. And then after simplifying, we have the step 3, that is to integrate and find the arc length. Let us now see whether these steps still works on exponential functions. That is in our next example. Here we have a curve which is expressed in terms of an exponential function. Find the arc length of this curve, where t equals 0 to t equals 1. For the solution, let us first write our curve, which is r of t equal to this one by the given. So our step one, we have to find the derivatives. So here you have your x of t. So that's why dx over dt is equal to still the same, a raised to t, because when you derive this one, it won't change. Now for dy over dt, when you derive this one, note that you first isolate the negative and then derive this one. So you just simply copy and then derive the exponent by the chain rule. So this one results to e raised to negative t. Now for dz over dt, we have this one. So the derivative is square root of 2. So our r prime of t is equal to this one. So this for the first component, this one for the second component, and this one for the third component. Okay, let us now proceed to step 2. Is to simplify the magnitude of r prime of t. The magnitude of r prime of t is equal to this one. So still, you input this one squared, this one here squared, and this one you also square this one. This is where most students make mistake. There's a trick to remove this square root. If you look this one closely, you will notice that this one is equal to 2. And this one is also equal to 2 times e raised to t times e raised to negative t. Since when you multiply this one, this is simply equal to e raised to 0, which is also equal to 1. So, we apply that one in our solution. We may rewrite this radicand into something like this. So here is the equivalent value of your square root of 2, and this one for this first term, and this one as your last term. So if you let this one to be your u and this one as your v, then you will have u squared plus 2uv plus v squared, which is a form of special product. So here, this is actually equal to u plus v squared, where your u is equal to e raised to t and your v is equal to e raised to negative t. So this one is simplified to u plus v squared, so which is equal to this one. So since this is your u and this one is your v, so you have this one squared. And notice that you can cancel this radical sign and this squared. Therefore, this implies your magnitude of r prime of t is equal to this one, e raised to t plus e raised to negative of t. For step 3, we have integrate. We may note that the integral of e raised to kt dt is equal to this one. Since we will integrate e raised to negative t, so this one will have k equals to negative 1 in later part of our solution. Now, for the length of arc, we have the integral from 0 to 1 of the r prime of t dt. Since r prime of t, based on our previous calculation, gives us et plus e raised to negative t, so this one is integrated to e raised to t plus this one. So by this formula, this gives us this integration. And this is to be evaluated between 0 to 1. So here, what we have is e raised to 1 minus e raised to negative 1 minus e raised to 0 minus e raised to 0. And this one cancels out to 0. So this gives us the value which is equal to this one. And this is how you obtain the length of arc of this curve. So we have seen that the step still works on this problem with minor trick on the simplifying of the magnitude. Let us now try to solve this third problem. Here, the arc length is given and the curve is given by this one, so it's quite messy. You are asked to find k such that the arc length of this curve from 0 to k is 16 over 3 units. Now, for the solution, before we start with our steps, let us first simplify the curve. Note that 2 sine t cosine t is equal to this one. And if we divide to both sides, what we'll have is this one. So we replace the first component, sine t cosine t, by this term. So now, if you write your curve, instead of writing this one as the original curve, we replace this one by this one. So we replace the first term into this one. So here we have our step 1. Find the derivatives. So to find the derivatives, let us first find dx over dt. So our curve is equal to this one now. So this is equal to the derivative of this. So you have 1 half times the derivative of this one, which is cosine 2t times 2, which is because of the chain rule. Cancel this 2 and 1 half. This gives you cosine of 2t. We apply same steps on dy over dt, which is now we have 1 half times negative sine of 2t times 2. So cancel these terms, and that's why you will have negative of sine 2t. For dz over dt, so since when you derive this one, you simply multiply this exponent by this one. Since this one is the reciprocal of this one, that one should cancel out. So the remaining term is dz over dt. You have, when you multiply that one, that gives you the constant which is equal to 1. And for the exponent, you subtract this one by 1. So this one is we have 3 over 2 minus 1, which is square root of t minus 1. Therefore, your r prime is equal to this one. So the first term is your cosine 2t. Second is your negative sine 2t. And then finally, you have the square root of t minus 1. For step 2, we need to simplify the magnitude. Based on our previous calculation, this gives us this one. So the first component of our r prime, second component of r prime, and the third component of r prime of t. Now, you may notice that you can simplify this one into something like this. Cosine squared 2t, sine squared 2t, and this one should cancel out the square root. That's why you will have t minus 1. And based on an identity, this one is simplified to 1. It cancels out 1 and negative 1. This gives us square root of t. So equal to t to the 1 half. So step 3, you have to integrate. So this one, L is equal to the integral from 0 to k, since you need to find k here, and then the input is t to the 1 half. That's the magnitude of r prime of t. So to integrate this one, do your integration as usual. This gives you this simplification. So substitute k on t. So that's why you will have this one. And then you subtract this one by 2 over 3 times 0 raised to 3 over 2. And this one vanishes to 0. Since you have a given value for the arc length, let us equate that value to this 2 over 3 k raised to 3 over 2. So that's our step 4. So we have this one as our step 4. It is where we equate those values. And we need to solve for k. So since L is equal to 3 over 16, then 3 over 16 is equal to 2 over 3 k raised to 3 over 2. So you divide both sides by 2. That's why this one is 8, this one is 1. And then you multiply both sides by 3, and this one cancels out. So this one is simplified to 8 times k raised to 3 over 2. Okay, so if you take the cube root both sides, you will have 2. And then squared both sides, this gives you a value of k which is equal to 4. And that's how you obtain the value of your k. So what we did here is we first simplify the curve and then do the usual steps, which is finding the derivatives, simplifying the magnitude, and integrate. We simply add another step for solving the values of k. So here we obtain a unique value of k which is equal to 4. If you want to learn more about calculus, see you in our next video.